Templating splashbacks, we template in a very similar way to what we would do worktops. The only difference is we need to manipulate a lot more of the data to get an accurate measurement, whereas you can just take the measurements directly off of worktops. With this, we need to scale down a little bit more in areas to be able to get a proper, clear measurement, because the laser's not very good at kind of taking carcass measurements and this, that, and the other, because there's no definitive place for it to measure from. So what we do in this scenario is I use my little templating plane blocks. I know that measurement from one end to another is 64 millimeters. So what I'm doing is I'm just going to draw some little data lines all the way around that are basically 64 millimeters away from everywhere I want to measure in the room. And when I take those measurements in a little while, I will then scale them back to their correct location in real life. We do that on site so that we can check everything. But in essence, we obviously need to template around the window. We need to know where all the window edges are. We then extend the end panel up so I know where the end of the end panel is, because obviously on my worktops I have overhung that end panel by 20 mil. So if I take the same measurement on the wall and then extrude that by 20 mil, they should be in exactly the same location. Once I've got all that data drawn out on the wall, what I then do is I then get a piece of worktop which is the same depth as what we've got going in, and I mark a couple of marks on level bits of worktop, level bits of carcass, sorry, on basically which to take my data from. So setting the plane on the wall is slightly different to what we do on the worktop. So what we need to do is we now need to do an equilateral triangle, but from left, right, and then up. Instead of going back to front like we did on the worktop plane, we now need to do an equilateral triangle, and the last point, instead of being further back, now needs to be up. So what we're going to do is, once again, it's got to be above 300 millimeters. In essence, drawing out an equilateral triangle at anything above 300 mil, as long as it is as accurate as you can make it, that will be an accurate plane to set from. So I've drawn out my 3 marks. Go to blank, and then you can see once the laser is still connected, you don't have to do any startup procedure like we did on the worktops. It will automatically go into the setting the plane mode, and it won't let you take data until you have set that plane. So now we go left, right, and now up. And when you do this, if it is under 300 mil, even if it is really accurately done, it will still tell you that your plane might not be as accurate as it should be because you haven't done it to over 300 millimeters. You are able to template in this, but it's obviously data might not be as accurate, but in some scenarios you have to do it because you just haven't got enough wall space to be able to get a correct measurement. So now in essence what I'm going to go and do is take all the measurements. So I don't bother trying to shoot the bottom of the carcass. I will shoot the line that I've made, which is at the worktop level, because obviously that's where the splashbacks are going to be starting from. So I will take my worktop level. Everything will be rotated to this on a wall. So now we can now start taking the rest of the data lines, starting with where the end panel finishes. And we'll slowly start drawing out the dimensions that we need on the walls, ready for later manipulation. Rotate into that bottom edge, colour things as we go, just like we do on the worktops. Now, I did scale down the outside wall here, but I'm pretty happy that the laser is going to take an accurate measurement, because the dot hasn't kind of elongated at all. So I take the wall measurement directly off the wall and don't use my 64mm, so I don't need to manipulate that data. Now here you can see I'm now going to take my first bit of the 64mm data, which is going to be where my sill finishes. So just like we did in the worktop template, if you're going to use any data that needs manipulation, you do it as soon as you've taken the measurement or set of measurements so you don't forget. Because obviously it'd be very easy for me to leave that in that place and then suddenly all my measurements are 64mm out from where they need to be. But once you get yourself into the habit of doing it, it's really simple to do that. So now I'm just offsetting that 64mm downwards to where it needs to be, removing the old bit of data because we don't need that. That was just a means to an end. And now we can carry on getting the rest of our data in this scenario where the reveals actually start. Once again, it's 64mm out here. Move it straight in, remove the old data. Now that should be as accurate as I can humanly possibly get it without taking the data directly off the window itself. Final bit. Move that 64mm in. And that doesn't have to be a 64mm thing. You guys can use whatever tools you need. You could do it by tape measure if you want to. It's just how I've done it is those little planes are 64mm, and that's just what I use just to easily draw out the scale of the wall basically. Now to get my height in this one, obviously we're coming off the left hand side there. So we obviously want these two to be the same. I'm just going to use that measurement that I've already got on the left hand side to make sure that they meet up nicely. So rotating to that bottom edge, as everything on the wall is coming off that bottom edge, I'm just going to offset that height, and that gives me my finished height. And that will give me a finished 90-degree height from the base all the way along, as long as you rotate to that bottom edge first. So now, just like we did in the worktop edit, we're going to connect everything up. And now we can start manipulating the data to get it to the correct point. So obviously what we're going to do is check that line that I drew on the wall I did with a spirit level, but that won't necessarily be 100% perpendicular. So what we're going to do is rotate to that bottom edge, use the line tool to create a perfectly 90-degree line from that bottom, and you can see it's out. That will probably only be by 0.5, 0.6 mil, but it's out. So removing that bit of data, refilling it up, and then recoloring it will now allow that edge to be perfectly 90-degree to my bottom of my worktop. So now the bottom, the right hand side and the top are all perfectly square. This is the time where you go around and check measure. So using the data you've got on screen, use the distance tool, check your dimensions everywhere you need to kind of just see whether you're shooting correctly. And now we can start doing some data manipulation to how the worktops and the splashbacks actually need to finish. So in this scenario, obviously we need to make because we're going to be going into the window reveal, we're going to make that front bit of worktop overhang by the thickness of the cheeks that are going in. We want the windowsill to sit on top of our quartz rather than to what's there, so we want to make sure that the quartz is higher than what is there currently, and make sure it's square, because once again I've taken measurements from the wall which won't be square, and we want to make sure it is. So using the line tools and the filleting tools just to make sure that all the data that we're about to basically put on the CNC machine is nice and square. The only one you don't necessarily want to do this on is things like walls or anywhere where you need to scribe it. So obviously, like I'm trying to show here, we're going to have a worktop overhang on the right hand side of that end panel, so we need to make sure that we follow the same line on the splashback. You can see that top line at the moment is segmented, and you know we currently don't want, we need to fillet all that together. This is me just taking into account the fact we've got a splashback on the other wall going in, so I need to take some meat off the splashback there. Now to join this up, if I was to just fillet this, what would happen is you'd lose some of the data on one side, so what's best to do is to use the remove segment tool and erase the segment, and then what that will do is that won't remove any data, that will only remove the data that you're asking it to remove. So now to add in cheeks here, what I'm going to do is just use the backsplash tool that I use on the worktops, add my cheek dimension that I need to do, and then use the 2 points to easily create a cheek of basically a square box. which I can then just move about to wherever I need them to be moved. But that's a lot easier than manually adding a box in, because then you're going to need multiple dimensions. So using the backsplash tool, that will be the exact dimension whatever I click it. So in this case, obviously, those two now will be exactly the same height as what as the area that I've clicked. So using the slab layout tool just to move the data out of the way. This is a really crucial bit of kit to just keep your data separate, move it without manipulating it at all. And now I need to make a sill. So once again, I can use the same tooling, use the backsplash tool, and then manipulate afterwards. Obviously you want to be checking whether the window's running out, so in this case you check your 2 reveals. After you've checked your reveals, what you want to do is use that backsplash tool, enter one of your dimension sizes, and then the aperture you wanted to go into, and it will create you a box which is perfectly square to those 2 dimensions. Just moving a little bit more data out of the way. Now move your sill out of that gap, because obviously it's a lot easier to manipulate that data once it's moved out of that hole. Now in this scenario I need to reduce one of the sides of that because the sill is running out by 5mm. So what I'm going to do is just move a 5mm line in, fillet it on one side only, erase, and then use the segment tool to join them back together. And then what that will do is that will run it out at the distance obviously between the 2 points. So one side is 165, one side is 170. If you add them 2 together, that will now be running out at that degree and join it as a perfectly square line. Adding the front overhang on the sill, which in this case is going to be 30mm. And this is going to be a square sill, so no horns on it, so we can just fillet them 2 together. Adding sockets into a splashback is quite a simple tool. I use 2 ways of doing it. If you can get an accurate point on one of the tabs inside where the sockets go into, then just add a bit of masking tape over it and take a cross measurement. So in this scenario we're onto another wall here where we need to add 3 sockets. So what I've just done is added a bit of tape. My laser can clearly see that point. I then ensure that my laser point is basically exactly where that screw hole is going to be going into. And then I will take that bit of data. I don't need to take the next one because I will go and measure where that next hole is. And then once I measure that hole and move it over into that place, we'll know exactly where the socket location needs to be. I know in this scenario that all double socket holes, the holes are 120mm between each other. So from one of those holes to the next will be 120mm. If that first one has been taken correctly, the next hole will be 120mm away, and we will go and double check this in real life. But for now, we now need to go on and add in the rest of the sockets. So same thing again. I'll go and do my double socket hole. Move 120mm over to make sure I've got my 2 points. And then now my single socket hole, looking at where that location is going to be. If I wanted to double check, but I can't see where that hole is, because I can't obviously see behind that corner, I use a socket screw to actually extend that through. And then what I'm going to do here is extend the line through, bring all the data down onto one line. We like to square them all up. No sockets are going to be perfectly level, so we make them perfectly level. So I bring one line through, all the way through all socket points, and then what I'm going to do is just extend the lines to it, and then use the draw and then cross feature to add another little data point in the correct location. So what you'll be left with is a cross which is on a perfectly parallel point, and then you will remove the rest of the crosses And then that's just an easy way of squaring all the sockets up so they're all perfectly in line, and we take out all that human error that was being done on site. So adding the crosses down to the line and basically just in essence extending that line down, removing all the old data. So now we've got all of the sockets in the correct locations and all in one line. And this is your point now where you go and check all these. So what you're going to do is you'd go and measure all these in real life, make sure that all the socket holes are in the right places, and now you can add your drop-ins in. So once again, I've got a single hole drop-in and a double socket drop-in. That will locate to wherever you click it. So in this case, it's located to one side of the socket hole, and then what you want to do is just obviously assuming that you are rotated to the correct angle, which will obviously in this case will be the bottom of the splashback, is what you'd want to rotate to. You're then just going to move those socket holes perfectly even between the two socket screw locations that we've taken. This in essence will completely square up those socket holes for when we cut them out. You can go into really small increments on that distance if you wanted to. If you wanted to be really accurate, you could go down as little as a number you can kind of think of. Just checking that they're all in the same location and centered. Just want to move that over another 0.5 mil. So final one, dropping that double socket there. Use the slab layout tool just to move it over. Obviously it will move over whatever is selected here. So if you don't deselect one of those little screw location holes that we took, it will also move that screw location hole as well. But the undo feature will be fine here just to get rid of that if you have done it. Now finally, with all drop-ins, if you change the color of it, you change the entire color. If you don't want to change the entire color, what you're going to do there is press no when it says do you want to change the entire color, and then what you're going to do is that will allow you to change individual data. So here, if I said yes, it was going to delete the entire drop-in. If I say no, then it will delete just the data that I need to be deleted.